Let's go to worked out problems in this topic. Problem 1. Which one of the following statement is correct for MOSFETs? A. P-channel MOSFET is easier to produce than N-channel MOS. B. N-channel MOS must have twice the area of P-channel MOS for the same on resistance. C. P-channel MOS is faster than N-channel MOS. D. P-channel MOS has higher packing density than N-channel MOS. This is given in IES ECE 2009. Solution. P-channel MOSFET is much easier to produce than N-channel MOSFET. That's why the option is A. Option is A. Question number 2. The measured transresistance transconductance GM of NMOS transistor operating in the linear region is plotted against the gate voltage VG at a constant drain voltage VD. Which one of the following figure represents the expected dependence of GM on VG? So we have to find out VG versus GM, VG versus GM, VG versus GM, VG versus GM. This gate EC 2008, 2 marks. The option is, if you calculate GM of a transistor operating in linear region, plotted against gate voltage VG at a constant VD, this is the form, GM versus VG. Therefore, option is A. A is the option. Let's go to common database, common questions. Look at the figure. In the 3-terminal dimensional view of a silicon NMOS, delta is 20 nanometer, transistor of width 1 micrometer. The depletion width formed at every p-n junction is 10 nanometer. The relative permittivity of silicon and silicon dioxide layer respectively 11.7 and 3.9. And epsilon naught that everybody knows 8.9 into 10 power minus 12 farads per meter. So look at these dimensions given to you and we need to solve the problems from the dimensions given to us. For example, this is 1 micrometer, 1 nanometer. This delta is mentioned as 20 and the thickness is already mentioned here. The relative permittivities are mentioned here. So based on this data, we have 2 questions. Let us see the questions here. The first question on the database, in our sequence, the third problem, the source body junction capacitance is approximately 2 femtofarad, 7 femtofarad, 2 nanofarad, 7 nanofarad. Gate EC 2012. 2 marks, because generally in common data questions we have 2 marks each, therefore total is 4. Now what is given to us? Epsilon naught is 8.9 into 10 power minus 12. Epsilon or epsilon silicon 11.7. Area is length into breadth, 1 micrometer into 0.2 micrometer. If you multiply, you will get 0.2 10 power minus 12. The distance is, the distance between the plates 10 nano, that means 10 power minus 8 meters. The area junction capacitance is given by epsilon A by D, and that epsilon naught is given as 8.9 into 10 power minus 12. Relative permittivity of silicon 11.7, 0.2 into 10 power minus 12 by 10 power 8. This is 2 femtofarad. Therefore, the option is A. Now, second problem on the same data, that's how in our sequence it is fourth problem. The gate source overlap capacitance is approximately 0.7 femtofarad, 0.7 picofarad, 0.35 nanofarad, 0.24 picofarad. GATE EC 2012, it is 2 marks. So let's calculate this. Solution. Epsilon naught is given as 8.9 into 10 power minus 12 farads per meter, and epsilon r here is a silicon dioxide layer, it is 3.9, and the area is of course 1 micro into delta, that is the data value given here, and from D is 10 power minus. So basically what changes here is epsilon r changes here, and then other parameters if you substitute, you will get 0.7 femtofarad. So it is, option is A here. Problem number 5. Assert MOSFET perform very well in parallel operation. Reason. MOSFET has a small turn of time. Options. Both A and R are true. R is correct explanation of A. B. Both A and R are true. R is not the correct explanation of A. C. A is true. R is false. D. A is false, but R is true. That is IES EEE 2007. Let's see the options here. A. MOSFET has a high frequency devices, therefore perform very well in parallel operation. High frequency. MOSFET has small turn of time because it has only majority carriers. Therefore both A and R are true, but R is not the explanation of A. Therefore our option is B. Option is B. Problem number 6. Two MOSFETs M1 and M2 are connected in parallel to carry a total current of 20 amperes. The drain to source voltage M1 is 2.5 and that of the second one M2 is 3 volts. What are the drain currents of M1 and M2 when the current sharing series resistances are 0.5 kilo ohms? Options: 10.5 milli, 9.5 milli, 9.5 milli, 10.5 milli, 10.5 milli, 10.5 milli, 9.5, 9.5. This is IES EEE 2009. So please understand, EEE also they are asking such a very big questions or important questions. How to solve this problem? Very simple. Take two MOSFETs parallelly, M1 and M2. This is VDD. Drain resistance is 0.5 kilo, 0.5 kilo, and this is voltage VG. And VDS1 is given, VD2 is also given, and then you have to substitute them there. Okay. Now how to answer this? Option is very simple. Now good look here. 10 minus VD voltage here by, so 10 minus VD1 by 5 kilo, VDS2 minus VDD minus VDS1 by 0.5 kilo, VDD minus VDS2 by 0.5 kilo, it should give us 20 milliamperes. And when you say 20 milliamperes here, and the total value is we substitute, and you can solve for VDD 7.75. And if you do that, now come back and substitute 7.75 minus 2.5 by 0.5 kilo, 10.5 milli. 7.75 minus 3 volts by 0.5, this is 3 milli. So answer is 9.5 and 10.5. So therefore option is A. So this is how you can solve directly. Problem number 7. Match list 1 with the list 2 and select the correct answer using the code given below. For example, BJT, mass capacitor, laser diode, JFET, population inverse, pinch off voltage, early effect, flat band voltage. Whatever you know confidently, you try with that. First, we know very confident, BJT is linked to early effect. So A is 3. That means option can be A or C. Second one you are very confident is JFET pinch off. So D is 2. So 3 is here, 2 is here. So we can't finalize. We need to take the option of B and C. Mass capacitor is flat band voltage. Laser population inverse. So option is C. When you look here, BJT has early effect, mass capacitor has flat band voltage, laser diode principle is population inverse, and JFET has pinch off voltage. Therefore, option is C. Question number 8. The regions of operation of a MOSFET to work as a linear resistor and a linear amplifier. The regions of operation of MOSFET to work as a linear resistor and a linear amplifier. A. Cutoff resistor and saturation. B. Triode and cutoff respectively. Triode and saturation respectively. Saturation and triode respectively. See, when you say amplifier, definitely it is saturation. Therefore, in this we have option is triode and cutoff respectively, and therefore option is B, because triode and cutoff respectively. Therefore, option is B. Problem 9. Statement 1 and 2. Statement 1. MOSFETs are intrinsically faster than bipolar devices. That is true. Statement 2. MOSFETs have excess minority carriers. That is wrong. No minority. So both statements are true. That's wrong. So both statements cannot be true here, because in MOSFETs we don't have any minority carriers. Therefore, let's see the statement here. MOSFETs are intrinsically faster than BJT because the rise time is less since the only majority carriers. Therefore, first statement is true, second statement is false. When first one is true and second one is false, the option is C. Last question. Consider the following devices: BJT in common mode, BJT in CE mode, and common base mode and common emitter mode, and JFET and MOSFET. We need to take the correct sequence of these devices in the increasing of the input. The lowest is common base. Next, highest is common emitter. After that, JFET, finally MOSFET. Therefore, the sequence is 1, 2, 3, 4. That means option is A. 1, 2, 3, 4. Option is A. That completes DMOS and in all the problems.